So we're going to graph some quadratic functions and we're going to give the domain and range. So there are 3 of them, and we're going to look at the directions. We're going to do what they say to do, and we'll go from there. Okay. So this first one, it says graph the function, give the domain and range. It is in the general form, okay? And they want us to do this by plotting points. So to do that, I'm going to make a table of values. So here's x, here's f of x. The first one I'll write out, but then after that I'm not going to write them out. Okay, so let's say I put in -2. A lot of times we use -2. Let's see what happens. F of -2 would look like this. -2 squared minus 4 times -2 minus 2. And you can do this for each one of the points you're going to pick. What you have to do, since we know it's quadratic and it's going to make a parabola, you have to plot enough points to see where the vertex is and get where that curve is going to happen. Okay, this winds up being 4 plus 8 minus 2. So what's that? 12 minus 2, which is 10. A little big, but it'll fit. -1. Okay, now I'm just going to plug in -1. I'll semi-write this one out. How's that? -1 squared minus 4 times -1 minus 2. Okay, that's 1 plus 4 minus 2. 5 minus 2, 3. Okay, I guess I wrote it out a little more. F of 0, that's the easy one. 0, 0, you're going to get -2. All right, let's put in a 1. What do I get for f of 1? 1 minus 4 minus 2, so that's that, -5. You'll notice it's still decreasing. It went from 10 to 3 to -2 to -5. Let's see what happens at 2. So I'm putting 2 in, squaring it, that's 4. 4 minus 8 minus 2. Looks like I'm getting, what, a -6? Okay, I'm getting there. I have to go till something repeats. If I plug in 3, what do I get? 9 minus 12. What's 9 minus 12? -3 minus 2, -5. Okay, there we see some matching up occurring, right? Those are the same outputs. That's when my parabola is going to kick in, okay? So let's do 4, and then that should be enough for us. We suspect that we're going to get a -2 output. So let's write this out. F of 4, 4 squared minus 4 times 4 minus 2. That's going to be 16 minus 2, which is a -2. Again, you see that matching up. Okay, so let's graph these points and see what it looks like. -2, 10, it's way up here. -1, 3. 0, -2, 0, -2, 1, -5, 2, 3, 4, 5. I need to scroll up just a little bit. Okay, and then 2, -6, 3, -5, and 4, -2. Now, that's the parabola we have. I want to show you something, though, that's really helpful when you're graphing parabolas. Your axis of symmetry is right here. Okay, so it's symmetric. See how you go 1, 2, 3 to get that point to the left? 1, 2, 3 to get another point to the right. If you do that, it gives you more points and you can have a better parabola. Same thing up here, you're counting 1, 2, 3, 4 points to the left. So count 1, 2, 3, 4 points to the right, because it has to be symmetric about that axis of symmetry. Okay, now I can graph this. Try to do your best. It's a pretty big parabola. We really could have gotten away with just these points. The problem is, how do you know where the vertex is? When it's in general form, you don't necessarily know. That was the point of doing, though, the plotting by points, okay? We're learning by discovery. All right, let's go to the next one. They want us to, oh, we didn't do the domain and range, darn it. Okay, so the domain here was all real numbers. And the range, remember you have to go from the bottom, which is right here. Our lowest point was -6. And it was facing up, so up to infinity. Okay, that's a parenthesis there. All right. The next one, we're expecting it to be a shrink because of the 1/2, and we're expecting it to be upside down because of the negative, okay? It says to compare this to y equals x squared and y equals 1/2 x squared. You could do this by plotting points. Let's do that first. Then we'll do the comparing. This is g of x this time. Okay, so let's say I put in -2, -1, 0, 1, and 2. When I put in -2 and squared, I get 4. 4 times -1/2 is going to be -2. When I put in -1, I'm going to get 1. And then here I'll get -1/2. When I put in 0, I'm going to get 0. When I put in 1, I'm going to get -1/2. When I put in 2, I'm going to get -2. You can write all of those out by using this equation. Okay, let's see what the graph looks like. -2, 2, -2, -2, -1, -1/2, so it's about there. 0, 0, 1, -1/2, and 2, -2. Well, I'll do it in green. Still has that parabola shape. You could find more points. 5 is generally, we want 5 points for a parabola. Now let's look at what the y equals x squared looks like. Okay, go back to what you know about y equals x squared. You got to get familiar with these points so you can graph a parabola quickly. That is y equals x squared. Okay, now I'll do it in purple. Hopefully this works. If you did it in purple, you would be cutting your outputs in half. So it would look like this. That would be the y equals 1/2 x squared. So when we compare them, you look at the original, this one, and it's just a regular parabola. The purple one is, shrunk. It's like compressed, like somebody sat on it. And then the green one, because of that negative sign, it's upside down. It's reflecting about the x-axis. All right, we've got one more. You can see what this is going to do. It's going to be very similar to the last one, but it's got a horizontal shift. It should be shifting 4 right and 3 up. Now, here's what I do, especially for people who are just starting with these. I say, okay, make a table of values. What you want to do is you want to think about, because this is in vertex form, our vertex is at 4, 3. That's great that we know that. We can tell just by looking at it because we know what H is. There's the H. There's the H. There's the K. All right, put that right in the middle, 4, 3. And then if you want to pick 2 points to the left, so 3 and 2, and 2 points to the right, 5 and 6, you'll get lovely points for your parabola, okay? And you can plug them in. All right, so if I put in a -2, if I put in 2, I get -2 squared is 4. -1/2 times 4 is -2, plus the 3, I get 1. If I put in 3, I get a -1 squared, which is 1. I get a -1/2 and 3, which is going to be 2.5. Okay. So far so good. If I put in a 5, I get 1. I get a -1/2 and 3, which is 2.5. I should put 2.5 probably. And then if I put in a 6, I get 6 minus 4 is 2. 2 squared is 4. 4 times -1/2 is -2, plus the 3, and I get the 1. Notice the matching up is occurring. Okay, so when I go to graph these, 2, 1, it's right there. 3, 2.5, it's right there. 4, 3, that's my vertex. right there. And then 5, 2.5, and 6. And so I get this cute little parabola. It's shrunk a little bit. But that's what it looks like. Okay. It says to compare it to part B. So it's like this one, but you shifted it to the right 4 and up 3. See how it's shifting? It used to be here for the vertex, and it went 4 and up 3. I forgot to do the domain, so let's do the domain. Let's go back here and do the domain. The domain for the green one, we're looking at the green one. Domain is all real numbers. Whoops, negative infinity to infinity. And the range, now the range this time is going from negative infinity up to 0. It's going from the lowest on up. Okay, and that's the range. All right, let's look at the domain and range here. The domain, all real numbers, negative infinity to infinity, and the range is going from negative infinity up to 3. Right here's where it's stopping. That's the highest output we had was 3. Okay? I want to show you one more thing with that last graph. So remember we had the little upside down graph. Remember we were comparing it, and it was like that. So you have to do a little bit of work to get that basic shape. But once you know the vertex is at 4, 3, which you can tell by looking at the equation, you can just say, okay, let me pick up my vertex, go 1, 2, 3, 4, 1, 2, 3. There's my new vertex, the new location for it. And then I can just use those same points, like treat it like the origin. Go down a half, 1 unit to the right and the left, and go down like a half from the vertex. And then the other one would be right there and right there. And so you don't have to necessarily do that whole table of values things. You could just use your transformations that we've been working on to get that graph. Okay? Sometimes it's a little tricky. Sometimes it's easier just to do the table of values. But this is what we're working on with transformations. I know we don't get a lot of time with it in chapter 2, so now we can apply it a little bit though here with these quadratic functions.